Okay, people are joining. Now I continue with the presentation. Now look here. So this is the flow chart we have seen. So in this flow chart, you have to carefully follow taking a molecule, and then you have to find out the name of the point group, and then that name is very important actually. Now look, I go to the next slide. Look at this table. So first molecule is a mercuric chloride, which is a linear molecule with the inversion center I. So AB2 type. Therefore, that belongs to the point group D infinity H. Take the hydrogen molecule. It is A2 type. That is H2. It is a linear molecule with the inversion center I. So that also belongs to D infinity H point group. Hydrochloric acid is AB type. It is a linear molecule, but it does not have I. Inversion center is not present because when you move in the opposite directions, you are meeting different environment. So it belongs to the point group C infinity V. You take a carbonyl sulfide. It is ABC type. It is also linear without I. It belongs to C infinity V. Water molecule AB2 type H2O. It is angular. Angular means bent structure. It is not linear. It belongs to C2V point group. Methylene chloride. What is the molecular formula of methylene chloride? CH2Cl2. Therefore, CH2Cl2. Therefore, it is of type AB2C2. It is tetrahedral structured actually, but a tetrahedral structure, but two corners are occupied by chlorine atoms and the two corners are occupied by hydrogen atoms. Therefore, it is almost, you can compare the water molecule and the methylene chloride molecule. In water molecule, two corners are occupied by hydrogen atoms and the two corners are occupied by lone pairs. Here, the carbon is at the center, two corners are occupied by hydrogen, and the two corners where the lone pairs were present in water molecule are now occupied by chlorine atoms. Therefore, it is also belonging to C2V point group. Chloroform is AB3C. You write the structure of chloroform. That belongs to C3V point group. Ammonia AB3, that also belongs to C3V point group. Boron trifluoride belongs to C3H D3H point group. Phosphorus pentafluoride AB5 type, that belongs to trigonal bipyramidal shape, which is D3H, and also tetrachloro pentaplatinate 2 ion. It is square planar complex, which belongs to D4H point group, and bromine pentafluoride, that belongs to square pyramidal shape, which is C4V point group. Sulfur hexafluoride, octahedral point group, and iodine heptafluoride is D5H point group. Now look at this picture. First one is trichlorobenzene. So three chlorine atoms are attached in 1, 2, 3, 4, 5 positions. 1, 3, 5 positions. Now look here. This molecule is exactly looking like a boron trifluoride molecule. In boron trifluoride, boron is at the center, one fluorine here, another fluorine here, another fluorine here. Structure is similar. Therefore, it contains C3 axis which passes through the center of the molecule. And here is one C2, here is one C2, here is one C2, and also along the C2 it has a sigma V, and moreover it has a horizontal plane also, where the molecule can be, the molecular plane itself is a symmetry plane. Therefore, it belongs to the point group D3H. It belongs to the point group D3H. Look at naphthalene. Naphthalene has only C2 axis. One C2 here, another C2 here, and one C2 which is perpendicular to the plane of the projection. Therefore, it belongs to the point group D2H. D2H point group. You draw the structure and follow the flow chart and try to find out. This is called glyoxal, transglyoxal. This transglyoxal is having C2 axis, which is perpendicular to the plane of your paper. Look, if you rotate about this point, then this oxygen will rotate and come here, and this oxygen will go there. Similarly, the hydrogen will come here, this hydrogen will go there. Therefore, it has a C2 axis. You cannot assume a C2 axis here, because if you rotate, O will come this side, H will go that side, and here also O will come this side and H will go that side. So C2 is not present here, and also C2 is not present here also, but C2 is perpendicular. But apart from this, it has a sigma H, that is the molecular plane. Therefore, it belongs to the point group C2H. This is called glyoxal, and this is a para-dichlorobenzene. I think this is also, it belongs to the point group D2H, similar to naphthalene. Look at this meta-dichlorobenzene. Meta-dichlorobenzene is something like water. You assume oxygen here, hydrogen there, hydrogen there. So similar structure. Therefore, this belongs to the point group C2V. So these structures you should draw first, and then you have to find out what are all the symmetry elements present, and then you have to try to do all the symmetry operations on these molecules and try to get identical configurations. And then you have to follow the flow chart to find out the point group of these molecules. So look at the next structures. So this is methyl chloride, 3H1Cl. Similar to ammonia. In ammonia, nitrogen is here, hydrogens are here. Instead of the chlorine, a lone pair is there. So it also belongs to C through V point group. So ammonia is also belonging to C3V point group, and methyl chloride is also belonging to C3V point group. Look at this. This is called sodium acetylide. As this is acetylene. If H is present here, it is acetylene. If H is here, then it will have I. As the H is not present here, it doesn't have I. Therefore, acetylene belongs to D infinity H point group, but sodium acetylide belongs to C infinity V point group. You try to find out the difference. You draw the structures of acetylene and sodium acetylide and prove that acetylene belongs to D infinity H point group and sodium acetylide belongs to C infinity V point group. Look at this molecule. Carbon, 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 one side O, one side O. This is called carbon suboxide molecule, carbon suboxide, C3O2, carbon suboxide. This also belongs to D infinity H point group. Look at this molecule. This is called methylene dibromide, methylene CH2Br2. This also belongs to C2V point group, as I've already told you. As in the case of water molecule, oxygen here, hydrogen, hydrogen, two lone pairs. Instead of the lone pairs, bromines are there. This is called methylene bromide, which is also belonging to C2V point group. See, this is called para-periodate, para-periodate ion. periodate, para-periodate ion. See, actually, these four oxygens are in a plane, and this one oxygen is above and the one oxygen is below. If you are not able to visualize this structure, I will try to construct a model and I will tell you in the next class. See, this square is in a plane, whereas one oxygen is above, one oxygen is below. This is called octahedral structure. Even in the coordination chemistry, you might have studied octahedral complexes. So this is an octahedral structure with a 5 minus charge. So this belongs to OH point group. So look here, methylene chloride is C3V point group, sorry, C2V point group. Carbon suboxide, D infinity H point group. Sodium acetylide, C infinity V point group. Methylene bromide, C2V point group. Para-periodate ion, octahedral point group. So these are all the various point groups according to the structures of the molecule. Now you follow the flow chart. If you follow the flow chart, is our time up? Anybody can tell me the time? Is it time up?
10:11, sir.
10:11. Okay, we have 9 more minutes now.
Yes, sir.
Okay, right. So follow the flow chart and try to find and identify the point groups of the molecule. So first question, is the molecule linear? If the answer is yes, then you have to ask, does the molecule have inversion center I? If the answer is yes, it belongs to the point group D infinity H. Otherwise, it belongs to the point group C infinity V. If the molecule is non-linear, then your question is, does the molecule have many CN axes of order greater than 2? If the answer is yes, the molecule belongs to cubic group. If the molecular formula is AB4, it is a tetrahedral. If it is AB6, it is octahedral. If it is A12, B12, it is hexahedral. If the molecule does not have many CN axes of the order greater than 2, then the next question you have to ask is, does the molecule have n C2 axis perpendicular to CN axis where n is greater than 2? If the answer is yes, the group is called a dihedral group. Along with this condition, if it has a sigma H, then it is called a DNH point group. If it has the n number of sigma D, it is a DND point group. DND, if the letter is not seen, you write down DN small d. And no plane, it is DN point group. If the answer is no, then does the molecule have a CN axis? Only CN axis. If the answer is yes, along with that, if it has horizontal plane, it is CNH. If it has n number of sigma V's, CNV. If no planes, CN. If it is no, then you have to ask the question, does the molecule have only the reflection plane? It is a CS point group. If it has only center of symmetry, CI point group. If it has only SN axis of order greater than 2, it is SN point group. If the molecule has only identity element, then the molecule is called C1, is belonging to C1 point group and is called an asymmetric molecule, totally asymmetric molecule. So with this, we come to the end of the class. All the best. Let us meet in the 5th hour.